Hello, everyone. In the previous videos, two videos we did basic derivatives, where everything was a function of x, and then we did derivatives, functions of x. That was called the chain rule. Right now, we're going to the derivative of two things multiplied together, two functions multiplied together. It's called the product rule. There's a formula that we use. We'll apply it to every problem. So let's go ahead and get started in doing the product rule for derivatives. So the product rule is not a new rule, like, for example, the derivative of a tangent or a cosecant. All right, it makes use of these rules right here when we have two things multiplied. So let's talk about what the product rule is specifically. So if we have a function, f of x, and for simplicity, we write it as f, and g of x, write it as g for simplicity, and another function h also. If y is the product of these two functions, f times g, then the derivative of y prime, is the derivative of the first function times the second, plus the derivative of the second function times the first. I don't like to memorize them as f and g because we could write them as any two functions. And we'll do that as we work problems out. But it's easier to do it for any variable or any symbol if you memorize this. It's the derivative of the first, no matter what the first is, times the second, plus the derivative of the second times the first. Now, what if we have three functions multiplied? Or four or five? They all follow the same rule. Basically, we do all the permutations on this. So if we have three multiplied, it's the derivative of the first times the other two, plus the derivative of the second times the other two, plus the derivative of the third times the other two. If we have four, we'll repeat the process, okay? The derivative of the first times the remaining three, the derivative of the second times the remaining three, and so on and so forth, okay? All right, so let's go ahead and do some problems, okay? So this is the first one. And again, here is where I like to be extremely, basically go in a systematic way solving these problems. So when I look at this, the first thing we observe is that we have two things multiplied. I don't care what these two things are. Right now, this is not the concern. Here we have two things multiplied because it's not a cosine by itself and it's not a power rule by itself. So I cannot use one of the techniques, above, like I cannot use this, for example, right away, or I cannot use this right away. Yeah, one is a power rule, the other one is a cosine. They're both functions of x, but they're multiplied. So these don't apply right away to them. So the first thing we do is we go ahead and label them. Here's f, here's g. And now we write the definition. Y prime is the derivative of the first times the second, plus the derivative of the second times the first. That's according to the formula I gave you on the previous slide. So now let's write them. F prime. If this is f, then f prime is 3x minus 2 to the 1/2 prime. And again, this whole thing is f. This whole thing is g. All right? Times g. G is cosine 2x. Plus g prime. Cosine 2x prime times 3x minus 2 to the 1/2. Now, if I look at this, I see, oh, I can use the power rule here. There's my u to a power. This is like u to the 1/2. And this is cosine of something else. Okay. And here, when I take the derivative of this, I pick it out from the list of derivatives as the cosine of u, and I know how to take the derivative of that. So now we can take individual derivatives based on the rules on the previous page. So how do we take the derivative of this? This is the power rule, the generalized power rule, they call it, because it's u to a function. Again, u to a power, some function to a power. Okay? So we have this thing to a power. So the first thing we do is we drop the power, that same thing to one less power. 1/2 minus 1 is negative a half, times the derivative of that thing. This here, all of it is this. This is f prime, basically. I still have to multiply by this. Plus, now I have the cosine of something. What is its derivative? It's the negative, the sine of something, times the derivative of that thing. Again, according to the rule above, the cosine of something is the negative of the sine of the same thing times the derivative of that thing. Okay, chain rule. And here is the power rule. You drop the power, that thing that we raised to a power, to one less power, times its derivative. So now we can simplify this. I can bring this down to the denominator. Okay, or maybe I can put a square root here, which is fine. Now, what's the derivative of 3x minus 2? Again, that's a straight line. Its derivative is its slope, which is 3. And then there's a cosine 2x sitting here. Oh, wait a minute. I didn't carry this down here. I need to do that. Don't forget to carry down all the terms. Plus, well, it's going to be a minus. The derivative of 2x is 2 times the minus times the plus is going to give me negative 2 sine 2x, 3x minus 2 to the 1/2. Okay. So we could write it as 3 cosine 2x over 2 square root 3x minus 2 minus 2 sine 2x square root of 3x minus 2. We can get a common denominator and simplify things, but the sines and the cosines are not going to add up. Okay. So it's good to leave it like this. So this is the derivative of the product of these two functions. Let's look at this one. Again, here I see, when I look at this, I see two things multiplying each other. So let me call this, let's change our variables, W, V. So now I can write y prime, derivative of the first times the second, plus the derivative of the second times the first. Right? What is W? W is the first factor. Take its derivative. Okay, that's W prime right here. And here I'm explicitly writing the primes like this because I like to keep track of my terms. Times V. V is the second term. Plus V prime. Here is V right here. So V prime is x minus 4 to the 3/2 prime times W, which is x squared plus 2x to the 1/2. Let's take the derivative of this guy first. Again, what do I see? I see some function to a power. U to a power. So it's the power rule. Again, there's no sine or cosine, tangent, cotangent, secant, cosecant. There's no exponential, e to the u, or a number to the u, or a log, or a natural log. If you go with the process of elimination, this is the power rule. But you should be able to look at it and say, oh yeah, it's a power rule. So I drop a power. That's something to one less power times the derivative of that something. This whole thing is the prime right here. Times the second one plus, now the derivative of this. Again, I see something to a power rule, drop the power to one less power, okay? So 3/2 minus 1 is a half times the derivative of that thing. So this is just that derivative. Then times x squared plus 2x to the 1/2 power. So we can simplify here things a little bit. We still have to take this derivative and this derivative. So here's 2x squared plus 2x to the 1/2. And now I have this, the derivative of this. What is that? Derivative of x squared is 2x plus derivative of 2x is 2. So that is this term right here times this term plus, here's 3/2 x minus 4 to the 1/2 times the derivative of x minus 4, this should be prime right here, is 1. Then times this right here. Okay. So we can leave it like this. Obviously, remove this 1 from here because 1 times all of these is 1 will just disappear. Or we can factor out x plus 2 to the 1/2, sorry, x minus 4 to the 1/2, and the 2 from the denominator. So maybe something like this. Here I have 2x plus 2 times x minus 4. When I take out x to the 1/2 from this, I get x 4 over the square root x squared plus 2x plus 3 times the square root of x squared plus 2x. All right. And we can get a common denominator here. On top here, we could get, we FOIL it out. We get 2x squared minus 8x plus 2x minus 8. And here we have a plus 3 times x squared plus 2x. The square roots, when they multiply, they go away. The square root goes away. So we can combine like terms if we wanted to. Again, it's up to you to the level of simplification. So I have 2x squared here, and I have 3x squared here. So I have 5x squared. Negative 8x plus 2x plus 6x here. X goes away. I have negative 8 over the square root of x squared plus 2x. For now, we could put parentheses because we have a small expression. There it is. Okay? If I didn't make any algebra mistake in simplifying, that's what the answer should be right here. But the main thing is the calculus up to this point right here. Okay. Chain rule, product rule. All right, here we have two things multiplied again. Again, this is all about the product rule, so we're going to expect things to be multiplied. So y prime equals the derivative of the first times the second plus the derivative of the second times the first. The first is 2 to the x, so here's 2 to the x prime times the second, tangent 4x, plus the derivative of the second, which is the tangent, times f, which is the first. There you go. So what's the derivative of 2 to the x? Again, from the rules that we have, this one is ln of 2 times 2 to the x, okay, times tangent x. So this is the same as this, okay, plus derivative of the tangent of 4x. So you have the tangent of something. Its derivative is the secant squared of that something times the derivative of that something. That's a chain rule. Times 2 to the x. We can factor out 2 to the x. ln of 2 times tangent x plus the derivative of 4x is 4. So 4 secant squared 4x. This is tangent 4x. So parentheses here is better. And that's all. There is the answer right here. Let's move on to another problem. All right, before we do anything here, let's change this square root into a power. So that's 2x minus 1 to the half times cotangent 3x squared. So let's call this half times g. By definition, y prime is f prime g plus g prime f. Derivative of the first times the second plus the derivative of the second times the first. So what's f prime? F prime. That's 2x minus 1 to the 1/2 prime times g, cotangent of 3x squared, plus g prime, that's the derivative of the cotangent of 3x squared, times the first, which is 2x minus 1 to the 1/2. Again, when we look at this, we see a power rule right away, a generalized power rule, where this is the u, or this is the function of x to a power. Derivative is drop the power, that function to one less power, times its derivative, the function I mean, right there, times the second term, the second factor, cotangent 3x squared. So this and this are the same, okay? Plus cotangent 3x squared, derivative of the cotangent is negative the cosecant squared of 3x squared times the derivative of 3x squared times 2x minus 1 to the 1/2. So here we have 1 over 2 to x minus 1 to the negative 1/2. What's the derivative of 2x minus 1? It's just 2. It's a straight line with a slope of 2 times cotangent of 3x squared minus this minus, will override this plus. Derivative of 3x squared here, that's 6x, right? We're doing 3x squared prime. The 3 comes along for the ride. The 2 gets dropped. X to 1 less power. So the root of 3x squared is 6x. So I'm going to move it to the front. Cosecant 3x squared times 2x minus 1 to the 1/2. Okay. So this 2 cancels this 2. I can factor out 2x minus 1 to the 1/2, negative 1/2. And I'll have a cotangent of 3x squared minus 6x cosecant 3x squared. And here I'll have 2x minus 1 times 2x minus 1. Okay. So it wasn't really necessary to factor this out. It's not like we can add anything out. But you could do that if you want. Okay. And this is the answer right here. All right. Another problem. I think we did something similar to this. So again, we have let's make it exciting. Let's change this here. Okay, this is a little bit different. So let's here take sine of ln of x. Let's do that. So again, I have some function multiplying another function. We write the definition so we know what we're doing. Derivative of the first times the second plus the derivative of the second times the first equals f prime. So here we have a sine of ln of x prime times g, which is the tangent 2x squared plus 1, plus g prime. That's the tangent 2x squared plus 1 prime times the first ln of x. Okay, let's take the derivative of this now. The sine of something. The derivative of the sine is going to be the cosine of that something times the derivative of the something. Here you go. This is this. Okay? Times the tangent 2x squared plus 1. Plus, I have a tangent of something, and I'm taking its derivative. So what's the derivative of the tangent? Is the secant squared of that thing times the derivative of that thing times the last term or the last factor ln of x. All right, so here we go. Cosine of ln of x. What's the derivative of the ln of x? It's just 1 over x times tangent 2x squared plus 1 plus. Now here I have a secant squared of this times the derivative of 2x squared plus 1. What's the derivative of 2x squared plus 1? The 2 is going to stay. I'm going to drop a 2, so they're going to multiply, give me a 4 to 1 less x. So that's 4x plus 0, or just 4x. I put it on the side here if you want. Should be comfortable with taking the derivative of this right now. Here's the 2. You drop the 2, x to 1 less power, just 4x. Okay? And then I have a secant squared, 2x squared plus 1 sine ln of x. And there is the answer. Yeah? Can't combine a whole lot, but there it is. Okay? Now let's take the derivative of this. This is a little bit involved. Let's take our time and solve it. Okay? So again, I don't care if it's a sine, cosine. The first impression when someone looks at this is they see that they have something, a function, times another function. So the derivative, by definition, derivative of the first times the second plus the derivative of the second times the first. And again, we systematically go through and fill in what we need to fill in. The first is ln of 2x minus 5 cubed. Now remember with the ln of something to a power, you bring the power in the front. Again, this is not a derivative or anything like that. This is a property of the log. So this 3 can come to the front. Okay? So I'm going to bring that to the front as I write f prime. So here's the 3 ln of 2x minus 5 prime. That is f prime times g cosine squared square root of x squared plus 1. Okay? Plus, this is wrong. The derivative of the second times the first. Sorry about that. So derivative of the first times the second plus the derivative of the second times the first. Okay? Again, that's why sometimes it's helpful to write the definition. So when you go and you're substituting things in, you may catch some mistakes like this. So g prime, here's g. It's cosine squared of the square root of x squared plus 1 prime times the first term. You could put it like this, or you could put it like this one. They are the same, okay? ln of 2x minus 5 cubed. Because this formula, I'm going to write it here, something to a power. You drop the power in the front. This could go both ways. If I have this, I can go ahead and drop the power and make it like that. And if I have the power in front of the log, I can bring it this way and make it so. So if I have 2 ln of x, I can write this as ln of x squared and bring the 2 up, okay? So derivatives, this one right here, 3 comes along for the ride. I have the derivative of the ln of something. It's 1 over that something times the derivative of that something. So I'm going to put it just on top right here. Because if I multiply 1 over 2x minus 5 times 2x minus 5 prime, this times the 1 is just going to be the 2x minus 5 prime. All right? Times the cosine squared of the square root of x squared plus 1. Plus, here we have to be careful. What do I have here? What's the first thing that we see right here? Do we see a cosine or do we see something to a power? If you were to see a cosine, what you would see is a cosine of square root of x squared plus 1. And that will be it. But here you have cosine squared of square root of x squared plus 1. Or you could write that as cosine square root of x squared plus 1 squared. You see something to a power. I don't care what that something is. Cosine, natural log, tangent, some really ugly function. At this point, it doesn't matter. At this point, I have something to a power in my head. I'm saying power rule. Let me apply the power rule. Okay? So let's apply the power. And again, this is the power of the chain rule. We're doing the chain rule here, and we're going to do it a couple of times in this problem. We already did it here, but for this derivative, we're going to do it a couple of times, and you'll see how. So again, first you need to know that cosine squared of theta is cosine theta squared. This is not the same as cosine theta squared like this. Okay? So these two are interchangeable. Sometimes you can put the power right on the cosine or put the cosine with the argument and then put the power in parentheses around it. But the power on the argument is different than the power on the cosine. So again, the first thing that we see is not a cosine. We see something to a power. So the power rule says drop the power, that thing, to one less power. So it was cosine squared. Now it's cosine times the derivative of that something. Times ln 2x minus 5 cubed. Let's repeat that. Let's put it in a form that you will see. So I have cosine square root of x squared plus 1 squared. And I'm taking its derivative. Right. Okay? It's the derivative. I have something to a power, u to a power. Drop the power. That's something to one less power times the derivative of that something. That's what I have right here. Okay? All right. Let's go ahead and keep working this. Here it's easy. 3. What's the derivative of 2x minus 5? This is a straight line. Its derivative is its slope. So here's the 2 over 2x minus 5 times cosine squared the square root of x squared plus 1 plus 2 cosine square root of x squared plus 1 times. What's the derivative of the cosine of something now? That's what I have. This is saying right here, if you look at it, take the derivative of cosine of something. Well, the rule says it's negative the sine of that something times the derivative of that something. You see? Times the natural log of 2x minus 5 cubed. Don't forget about this log right here. Yes, I can move this here a little bit. We're not done yet. We have to still take one derivative here. So here we have 6 over 2x minus 5 cosine squared of the square root of x squared plus 1 plus 2 cosine square root of x squared plus 1. Actually, it's a minus because I'm going to bring this out here. So here's times sine of the square root of 2x of x squared plus 1 times, what's the derivative of the square root of x squared plus 1? Remember, I can write the square root of x squared plus 1 as x squared plus 1 to the 1/2. So let's write it as x squared plus 1 to the 1/2 right here. I should have done that earlier. But here's x squared plus 1 to the 1/2. That was the square root. So when we look at this, what do we see? Again, we see something to a power. In our mind, power rule. Power rule, drop the power. That's something to one less power times the derivative of that something times the ln 2x minus 5 cubed. See how we're carrying on the chain rule? That's why it's called the chain rule. It's like a chain and a, in a like a chain link, fence or something like that. It's just you keep repeating one chain after the other. Okay, so here we go. We'll go over it one more time once we're done. So it's 6 over 2x minus 5 cosine square root of x squared plus 1. This here, to cosine something, sine something, this is a property of, this is the sine of 2 square root of x squared plus 1. You can simplify that. Here's the 1/2. 1 over the square root of x squared plus 1 times, what's the derivative of x squared plus 1? Okay, it's a derivative right here, chain rule, right? Derivative of x squared plus 1 is 2x plus 0 times ln of 2x minus 5 cubed. So here's the first part. Here's this 2. We'll cancel this 2. Because again, 2x plus 0 is 2x. 2 cancel out. I'm going to have sine of 2 square root of x squared plus 1 times x ln 2x minus 5 cubed over the square root of x squared plus 1. And we just leave it at this. We're not simplifying. We're not combining. Okay. So let's go over the second term a little bit. This one right here. So this was g. G was right here, cosine squared of x squared plus 1. The square root of x squared plus 1. So when it's time to take g prime right here, again, I see, again, yeah, it is a cosine, but the first thing that should come to mind, I have something to a power. It is a power rule. So you got to apply the power rule. So the power rule says, drop the power in the front. That thing, which is the cosine, to one less power, times the derivative of the cosine. Okay? So again, I have u to the n prime, and the u is the cosine square root, whatever is in the square root. And then the n is the square. And here's prime. 2, again, this is n, un minus 1 times u prime. There's the u. I drop the 2. U, which is the cosine square root to 1 less power, which will be 1, times the derivative of the u, which is the cosine square root prime. That's what I have. All right? Now, I'm taking the derivative of this. It's the cosine of something. Its derivative, according to the chain rule, is negative the sine of something times the derivative of that something. Well, here it is. negative the sign of something times the derivative of that something. And what I did was I changed the square root to a half. Now it's time to take this derivative. Everything else gets copied the same. You can simplify, you can combine things, but our main thing is to carry on the chain rule, one chain, after the other. So now I'm taking the derivative of this. What do I have? I have something to a power. Again, power rule right away. Drop the half. That's something to one less power times the derivative of that something. Now, when I take the derivative of this, I just have 2x plus 0. I can't take any more derivatives. There's no more chains in the, in the chain rule, take derivatives out. So this is it. I cannot take any more derivative. We stop. Okay. But we followed it really long. We took this derivative, gave us another derivative, gave us another derivative, gave us another derivative. Okay. And that's how we have to continue doing the chain rule. But in this case, we did the chain rule in a product and the setting of a product rule. Okay. So in the next video, we'll be doing the quotient rule. We did the product rule, excuse me. We'll do the quotient rule in the next video. Hope to see you there. Thank you.